This is our EE599 final project presentation. The topic of our presentation is Smart Blinds with Google Assistant integration. I'm Matthew Tarter, and Andrew DeRamsey will be joining us shortly. An outline of our presentation will be as follows. We're going to give an introduction, talk about our project overview, talk about the hardware of our smart blinds in depth, talk about the housing for our smart blinds, talk about the DC system, talk about our microcontroller, talk about the integration with Google Home, give a code walkthrough of our software, talk about how the tasks were divided between both me and Andrew, talk about what we learned throughout doing the project, our future work, and show a demo video of our project in action. As we enter the Internet of Things age, people are using technology to improve multiple facets of their everyday life. 12.86 billion IoT sensors and devices are expected to be in use in the consumer segment by 2020. Homes are becoming smarter, with personal assistants such as Google Home and Amazon Echo populating within the average person's home. Based on the increasing relevance of IoT devices for consumers, we have decided to implement a smart blind prototype as an example of what we can expect to see in the consumer market in the near future. The overall functionality of our project will be automated blinds that can be opened and closed by themselves or through Google Assistant or Amazon Alexa. These smart blinds can be programmed to automatically open or close to the desired level for different times of the day. One of the main needs that we found in our research was putting these blinds in a two-story, foyer entryway where people can't access their blinds manually. This is a hardware diagram of our entire smart blind system. We have a DC motor attached to our blinds, which actually turns and controls the tilt of the blinds. This DC motor is powered by our H-bridge device, which also powers our microcontroller. Our microcontroller has the software and the programming, which sends signals to the H-bridge device, which in turn tells the DC motor how much to turn and tilt the blinds. Our microcontroller is also connected to a Wi-Fi module that enables the integration with Google Home. We will talk more in depth of the overall system in the next few slides. This is the housing for our smart blind. For our housing, we utilize PVC piping as it is a very cheap and easy solution for a larger prototype that we had to make. It is very easy to work with and hollow, so we could run wire through it and conceal all of our components within it. Luckily, our components were small enough that they were able to easily fit inside the top of the set of blinds.
For our project, we decided to use a DC motor instead of a servo motor as we previously thought we would use, mostly due to the cost difference between the two. In order to purchase a servo that was powerful enough to open and close the blinds, it was going to end up costing us approximately $70, which is a lot of money for a school project, and we just didn't have it. So we went with a DC motor, as you can see in our figure here. This is the exact motor that we went with. It's a 6 volt 100 RPM motor. It lifted 1.4 kilograms at 6 volts, which is pretty hefty, and it was only $10. So unfortunately, the code for that ended up not being as good with the DC motor as it would be with a servo. We'll talk about that a little bit more later on in the slides, but just as a quick recap or quick explanation of that, the DC motor it doesn't know what its position is, obviously, whereas a servo would know that, would be able to run through different commands, whereas the DC motor is a very sequential command input to this because it's time related. In order to drive this DC motor, we had to buy an H-bridge, which was only about $5, so again, really cheap. The whole DC system was only about $15, and we ended up using a L298N H-bridge, which is this right here. It's for our third reference, but we use 12 volts, up to 12 volts right here on these blue pins. Of course, we use 6. This would be the motor output, the output for the motor. These would be the data pins to run from our microcontroller to control the whole thing. This is the MOSFET on it, and of course there's a bunch of other logic built into it. Basically, the way that an H-bridge works is you have your MOSFET here in the middle. I'm sorry, you have your motor in the middle, and then you have your MOSFETs that will transition based on what your input signal from your microcontroller is in order to spin the motor either clockwise or counterclockwise if these two switches are closed. So that's our DC system. As we said, we wanted to use a servo, but ended up going with a DC motor instead. Now on to our microcontroller. We ended up going with an ESP8266. This microcontroller was not necessarily the best choice for this project. We realized this too late as our code was mostly written and the project timeline had mostly passed. We found this out very recently. The microcontroller is very robust, it's small, and it's power efficient. The small size of the microcontroller was extremely important to us to be able to hide it inside the top of the blinds. The power efficiency was nice to allow for future power to come from solar cells, which is something we'd like to do later on. The major downside to this microcontroller is that it only has 2 GPIO pins. This means that we're not able to use a photoresistor or a temperature sensor as we previously were talking about doing. Unfortunately, this will decrease the complexity of our project, however, not by very much due to the WebSockets and our states for the motor already being written. The WebSocket was definitely the hardest part of this project, trying to interface and get if this then that set up with Heroku and talking to the microcontroller. Another reason that we actually went with this microcontroller is it has a built-in Wi-Fi antenna. After poking around the internet a little bit more, we did find some other ones that had more GPIO, but again, the time had passed for us to be able to purchase one and integrate it. So that's one of the big things that we'd like to do for future work on this project.
We used If This Then That to create applets to integrate with our Google Home and Amazon Alexa. An example of the applet is shown in the picture here. The applets create a database of information, which in our case holds the location of the device, the state of the device, and what the user is asking the device to do. Heroku is a service that we use to host that JSON database. It allows us to run a webhook through its website and connect the If This Then That service to an Arduino-based microcontroller. The database is accessed using the microcontroller via the Wi-Fi module talked about in previous slides. Anytime new data is added and based on the information, the microcontroller will send signals to the H-bridge and from there to the DC motor to change the tilt of the blinds. The data is populated using the voice commands with a Google Assistant device such as Google Home or Amazon Alexa device such as an Echo. For an example, we can ask the Google Assistant to set the blinds to 50%, and the applet will then send our necessary numbers to the database, which is then accessed by the microcontroller, and the blinds will tilt accordingly. Google will verify that it's processing the application.
So now for the code walkthrough. This is the main code for our project that was uploaded onto the ESP8266, which of course is our microcontroller as I talked about earlier. As shown in the code, we start with including our different libraries, of course, as you can see. And we go into our Wi-Fi setup with the Heroku web address. I took out my Wi-Fi password for my Wi-Fi network, the MIB, and just put in my password just for display purposes. And of course, the Heroku website is the EE599 smartblinds.herokuapp.com. Very cool website to go to and work through. So we have all of that. Then we go into more internet connectivity setup, our outputs for disconnecting, for connecting, and all of our WebSocket processes that go along with it. And that can also be seen in our demo it may be very difficult to see, but it can be seen on the surface when our serial monitor is monitoring the serial input. We can actually see all of those processes going through from when it connects to the internet, connects to Heroku, and as it gets commands from the webhook from Heroku. And we then go into the setup, which begins our serial reading, setting up our pins, putting our connections, setting up so that we can see that we are connected to the Wi-Fi and internet. And then we go into a loop to keep our connection between the ESP8266 and Heroku active, so Heroku doesn't kick us from the website. Because of course, if it times out, then it'll kick us from the website, which is never good when you're dealing with an IoT device. We then move on to our main section of the code, which is device location, state, and query. This would allow this project to be scaled to different rooms and devices. We were looking at some examples and working with example code and really found that was going to be very helpful, especially when dealing with webhooks. The code for the receive command is pretty much the same for each. For the is pretty much the same for all of the if and else if statements, which are as follows. The digital write writes a low or high signal depending on the pin to enable the H bridge. The message writes a message in terms of what state the microcontroller is in at that moment. The delay waits a certain amount of microseconds to allow the motor to turn on for that amount of time. This is where I was describing from our DC motor how it's a little bit less robust code versus a servo motor. So in our delay here at 2,000 milliseconds, we will, each one of these is actually 2,000 milliseconds. And this is due to the fact that at state 50, the blind will be at a 45-degree angle, and it will take 2 seconds to get there, and then 2 seconds to get to 90, to 135, and of course back up to 180. And then taking all that into account, will take 8 seconds to go from 180 degrees to 0 degrees. Unfortunately, that's just how the code is written, so the whole thing will still work. It just takes it a little, it's just very step through versus saying go to open 45 degrees and then go to open 180 degrees and then back to 0 degrees. And that's why we would want to implement that in the future. So, of course, 2,000 milliseconds is 2 seconds, as I had said. And after the delay, the pins are then back to low. So what this will do is this digital write, low and high, will turn on the H bridge. Then it'll delay. Of course, we'll go down to one that will actually run. It'll delay 2 seconds. So that way the motor will be on for 2 seconds. And after that delay, it will write low to both pins, which will then turn the H bridge off and will, of course, turn the DC motor off. After the state section, there's a sending response that sends a response back to the website and also on the serial monitor, as I was stating earlier. Basically, what that will do is say, okay, we're in state, for example, here we're in state 101, and you'll be able to read that on the computer with the serial monitor, and that also sends a response back to the web page.
This is our Gantt chart showing our task schedule. As you can see in the Gantt chart, there are 6 tasks. Task 1 was to secure all the parts and components with hardware, with Andrew leading. Task 2 was to sample code to make sure each component worked individually. Andrew also led that. Task 3 was to combine the microcontroller, the DC motor, and the Wi-Fi controller together to make sure that the core of our project worked, and Andrew led on that. Task 4 was to make sure that the Google Assistant or Amazon Alexa would send data to the Wi-Fi module, with me, Matt, as leading. Task 5 was to integrate Google Assistant and Amazon Alexa into the project and have it control the blinds with me as the leader. Task 6 was to complete the final project report and presentation, which I led that as well. While Andrew was working on the first couple tasks, I was working on how to integrate Google Assistant and Amazon Alexa so we could split up the workload more efficiently. And while I was working on the end of the project with Google and Amazon, Andrew was working on helping with the coding and putting in his necessary information into our paper and final presentation. Our learning outcomes for the project, we definitely learned how to code in Arduino and the Arduino IDE, the syntax of the language, and how to connect a non-standard Arduino board. We learned how to use the if this then that applets to connect our Google Assistants and Amazon Alexa. We ended up figuring out after our midterm report that we didn't need to use the Google Assistant software development kit. So we initially thought that the integration with Google Home and Amazon Alexa would be a lot more difficult, and it turned out to be a very straightforward process. We also learned how to use Heroku, which is our service that we host the JSON database on, that we can access via webhooks with the if this and that protocol applets, and connect to our microcontroller. And our lessons learned, we definitely learned that whenever picking out a microcontroller to use for the project, really need to do your research on how many input and output pins that it's going to have, and it was just too late in the game for us to try to integrate with our temperature sensor or our photo sensor so that we could have additional features to our smart blinds.
Now to future work. As I've previously stated, this is kind of going to be more of a recap. For future work in this project, getting a different microcontroller is obviously number one. It's the most priority task we would do, getting more GPIO pins, which, as I said, there are some out there that are still very small, but they have several GPIO pins, so we would be able to add our temperature sensor and photoresistor to be able to get those tied in, and which obviously would make this product a whole lot better. We would also want to change our DC motor to a servo motor to allow for more robust code, and of course we need money for that, which would be nice. After college, having a job, have money to buy a servo, we'd be able to integrate with our project and be able to control the blinds to set any rotation angle that we would want at any point in time. The other future work system that we'd want to upgrade would be our power system. Right now we're using a 6-volt desktop power supply, which of course is not ideal for a fully integrated product. We'd love to be able to use solar power with a rechargeable battery pack. One whole side of the smart blind at the top was empty. There was nothing in it, and it'd be great to be able to fill that with battery and put a solar panel on it, or some sort of easy way to charge it or something, which would lead to the next point of 100% transparent installation to the occupant. So when somebody walks in, they don't say, "Oh, you have all kinds of cords on your blind. That's really interesting." You would be able to pull your phone out or talk to your Google Assistant and be like, "Hey Google, turn my blinds off, closed," and they'd close, and you'd be able to amaze people with all of the cool things that would happen. And of course, future work, and those would be the main things that we'd like to focus on. And now for our demo video, we'll go ahead and watch this.
This is our Google Home Smart Blind. Our blinds are controlled using a DC motor connected to an H-bridge for power. This H-bridge is then connected to our UART controller, which holds our programming to operate the blinds. The controller also uses a Wi-Fi module to receive commands from the Google Home. This allows users to ask Google to open or close the blinds to their desired level. Now here's Andrew with our demo.
Hey Google, set blinds to 50% open down.
Okay, performing action.
Hey Google, set blinds to 100%.
Okay, performing action.
Hey Google, set blinds to 150%.
Okay, performing action.
Hey Google, close the blinds up.
Okay, performing action.
Hey Google, set the blinds to closed. Well, it's
Okay, performing action.